Hey guys, welcome back to another RSK Maths tutorial, and in this tutorial I'm going to be showing you guys how we can convert between polar and Cartesian equations. So our Cartesian equation is just anything in the form of y equals f of x, and the idea is that the Cartesian coordinate system uses a different sort of plotting method. So in Cartesian equations and Cartesian graphs, you actually plot by going along the x and up the y. So let's say we wanted to convert a Cartesian equation into a polar equation. And a polar equation is going to look like something like radius equals f of theta. Just like that. So let's say this is our Cartesian equation. Let me just do something like that. Okay. Actually, let me do something a bit more like that. Okay, this is better. Now ignore this over here and all this. Like, just pretend this was a valid graph. So this is our function y equals f of x, and we want to get it into the form of r equals f theta, where r is the radius and theta is the angle it makes. So we can look at any generic point here, and let's just call this xy. So we want to work out what this distance r is for in terms of x and y. What we can do is we can just draw this triangle, and now we see that x is actually going to be the base of this and y is going to be the height of this, and r is just going to be using Pythagoras, the square root of x squared plus y squared. We don't worry about negative because r can't be negative. So there's our first part. We've got r in terms of x and y, and now we also want to work out what theta is. So that's this angle here, and this, using trigonometry, we can just work out this is going to be arctan of y over x. So there we go. These are our equations which link r and x, r, theta, and x and y. And I actually should have written we're converting polar to Cartesian in this case. These are the equations you use to convert between polar to Cartesian. So if we had a polar, actually I'll just create all the equations and then show you guys how we use them. So these are the equations we use to convert between polar and Cartesian. Let's just write these down. So r is going to be replaced by x squared plus y squared, square root of that, and theta is going to be replaced by arctan of y over x. So there's what we use if we want to convert polar to Cartesian. We replace all the r's and thetas with this stuff. Now, if we have a polar graph, let's just draw in one of these, and I'll just have it something like that. Okay, so now we're converting Cartesian to polar. It's a bit counterintuitive because to derive these equations, we convert from polar into Cartesian, but these are actually the equations you use to convert the other way around. So you don't need to worry about this. You kind of just need to remember these equations which we're going to create. So if we have a generic point on the polar curve, this is r equals f of theta, and this generic point is just going to be, let's just call it r theta, doesn't really matter, and we want to represent it in terms of x and y. Okay, wait, let me write this. It's probably better to write it like this, r and theta. And what we want to do is we want to represent this point as an x coordinate and a y coordinate. So how are we going to do that? Well, again, we can just use trigonometry. So the x coordinate is just going to be the base of this, and a y coordinate is just going to be the height of this. X is equal to r cos theta, and y is equal to r sine of theta. So overall, this means this is actually what our point looks like, r cos theta, r sine theta, which gives us these equations. X equals r cos theta, and y equals r sine theta. So there we go. These are the equations which you need to know to convert between Cartesian and polar equations. Now let's look at an example of this. So let's say we have the Cartesian equation y equals x how are we going to convert this into a polar equation? Well, we can use our Cartesian to polar equations and kind of just replace everything. So let me use this. We replace the y's with r sine theta, and we replace the x's with r cos theta. And here's our polar equation. Now, obviously, we can just simplify this a little bit to ultimately get, if we move this over to there and then cancel r's on both sides, we're going to get tan theta equals to 1. And you'll notice that this polar equation doesn't actually have an r in it at all. So what's this actually going to look like? Well, if we draw the graph, tan theta is the same as opposite over adjacent, and opposite over adjacent, if we're thinking in terms of dy and dx, is the same as change in y over change in x. So therefore, this is just going to be a line with gradient 1. So on a polar graph, this is literally just going to look like this. It's just a line with gradient 1. And I don't think, it doesn't go beneath this because at this point it's a different angle. So it's a line with gradient 1 and only in the positive direction. That's why it has no resemblance on r, no bearing on r, because r is kind of just doesn't matter. The only thing that matters is that this angle is arctan of 1 or 45 degrees. So there we go, there's our example to convert Cartesian into polar. And now let's look at another example. If we're trying to convert polar, r equals 1, which if you don't know, this is just a circle of radius 1 because r is 1 at all points on this circle. And we can use our equation, polar to Cartesian. We replace all the r's with square root x squared plus y squared. So let's do that. Square root x squared plus y squared equals 1. And as you can see, if I square both sides, we get the equation of a circle. Nice and easily. So this is how you convert between Cartesian and polar graphs. The important thing is to use these equations which you've just derived. And yeah, thanks for watching, and I'll see you guys in a future tutorial. Bye.